In reality, there are two different type of data sets and two different type of errors when we look at it from a model building point of view. So till now, whatever data we used, the input data for building the model is called the training data set, and the error that we have been calculating is the training error. So we have an accuracy for the best model that is 95%, and we have an error of 5%. Now is that model really good? Yeah, on the face of it, it looks really good model. Okay, now error on the training data is known as training error. The low error rate on the training data definitely might not always mean the model is good. We need to be careful. A good accuracy on training data might not always result into a really or indicative of a really good model. What really matters is how is the model going to perform on the unknown data set or the test data set or the new data set that is going to come out. We need to find out a way to get an idea on the error rate on the unknown dataset or the test dataset. One easy way is to just keep a part of the dataset, do not use it in building the model. So remaining part, let's say I take 80% of the data and use it as training, and rest of the 20% of the data I don't touch it, though I knew the result, but still I build the model on 80% of the data and then find the accuracy on rest of the 20% of the data. Let me call it as holdout data or training test data. Then if the model is still doing good on that unknown data or the out of time data or the validation data, if it is still as accurate as training data, then we can believe the true predictive power of the model. So there are two types of data sets and two types of errors. One is training data set, that is the actual model input data. Test data set is the unknown data set or the validation data set that we keep aside to test our model. Once we build the model on the training data, we test it on the test data set to get the, it gives the final accuracy of the model or final model that is built on the training data set. Okay, generally we might not have all these two data sets at the beginning of any problem. Okay, sometimes we may have only train, sometimes I mean all the time we will have only training data set, or sometimes we'll have training plus test data set. So what we can do is, when we have only training data set available, we can take 90-10%. So out of overall data, we can take 90% of the data as training data, keep rest remaining 10% of the data as validation data set. Validation is nothing but the substitute to test data set, or it's a temporary test data set. So since we don't have the test data set, we have created the validation data set. Sometimes it is created with the rule of 70-30, 70% training, 30% validation, or even 80-20, 80% training, 20% validation. So we create the validation data set, and then once we have the training dataset and validation dataset, we build the best model on the training dataset, see its accuracy, call it as training error, look at the error on the test dataset, call it the test error. So there are two types of errors, like the way there are two types of dataset, there are two types of errors. Training error, so the error that we have been calculating till now, the error on the training dataset, it is also known as in-time error. The error on the input data, the error on the known data, or the error on the dataset that is used for building the model, okay, can be reduced. It can be reduced while building the model. In fact, this is what we have been trying while building the model. We have been trying to reduce the error as much as possible. We have been trying many iterations in building the model to reduce the error or the training error, okay, the test error. In fact, this is the error that really matters. So it is also known as out of time error, so out of time data error. the error on the unknown dataset or the new dataset. In fact, if a model is really doing good on training dataset, it should do good on test dataset. If it is not doing good, then that is not a really best model. It need to be rebuilt or recalibrated. Okay, generally a good model should do good both on test and training data. So we build the model on training, so training error should be less, and we validate it on test data, test error should be less. Both of them should be as close to zero as plausible. So if a model is very good on training data and it is not doing good on test data, that is called the problem of overfitting. Let us see what exactly is the problem of overfitting.